Okay, so without further ado, like I said, it is just a 30-minute whistle-stop tour of the most common flat roof defects. I could go on for hours. You don't want me to go on for hours, believe me. So we'll make a start anyway. Just to introduce myself, so my name's Steve Cookson. I've been in the roofing industry for over 28 years. Worked with a number of the kind of major manufacturers out there. So Icapal or Anderson's back in the old days, as it was when I joined. Seeker, HD Sharman, Roberts Group, who are part of Polyroof and Restec. I've also been nominated twice as technical chair for the Liquid and Roofing and Waterproofing Association. I'm a fellow director and also vice chairman of the Institute of Roofing. Probably my favourite job is husband and father of these three. As you can see, they're growing. I'm quite vertically challenged, as they say. My kids have outgrown me, so there's only my 11-year-old there but he's catching me up now. And in my spare time, I'm a junior football coach for my local football team, Hyde United. So that's where you'll find me on a Saturday, yelling on the touchline at these lads. So enjoy that side of it as well. Okay, enough about me. So like I said, we're going to just have a look at the existing waterproofing and the common associated defects just to start with. So the most common types of waterproofing that we find out there is felt, single ply, Mastic asphalt, and liquid waterproofing. So we'll just have a look at each one of those and see what the kind of common defects are that are associated with those systems. So obviously the first thing we need to do when we jump on a roof is identify what kind of waterproofing it is. So how do we identify felt? Well, it's usually mineral surface. That mineral surface, of course, can be wearing away, but it could be hidden under chippings. So scrape those chippings away, see if you can find the laps. So the laps are a dead giveaway underneath the stone chippings, whether it's asphalt or felt. And also covered in aluminium paint as well sometimes, but again, have a look for those laps so that you can identify whether it's felt or not. So probably the most frequent and common issue with felt is kind of a loss of mineral surface that we see on there. So that mineral surface, as I said, is there to protect the bitumen underneath. So the bitumen is non-UV stable. So if any rays from the sun get to that bitumen, it's going to cause a defect. So loss of mineral is probably one of the biggest causes of these defects that we see as well. Another common defect with felt is the laps. So you'll often see me running around on LinkedIn on roofs and probing at the laps of felt with my probe there. So felt laps can either delaminate due to age and the bonding bitumen becoming brittle, or probably more commonly is poor workmanship and around details. So have a look around any kind of details that you see. So outlets, upstands, anything like that, and have a look at the laps there. Quite an extreme example of delamination at laps on this. Must have been a cold day because I'm shaking. But you can see there, it's that not only is the lap started to delaminate, but the actual felts are started to delaminate from the substrate as well. So not a difficult defect to find on this roof to find the location of the water ingress. Another common one is around outlets. So when you get on a roof and you find out it's felt, have a look around the outlets because you usually find some delamination around there. The safest way to detail felt around an internal outlet is by installing new outlets with either a clamping ring, which I'll show you an example of, or a refurbishment outlet with felt systems. Usually comes with a felt flange around that allows the underlay and the cap sheet to be nicely bonded to the outlet, and forms a nice seal there as well with the the internal with the spigot, the downpipe, as another kind of example of delamination around an outlet. So if you see this on the inside of the building, which is the downpipe, then obviously check those outlets up there when you get on the roof. Just make sure there's no delamination around the outlets. So you got a bit of an example of a clamping ring. So if you see this when you're surveying the roof, you're fairly confident that clamping ring is doing its job. So in the top left there, you can see the nut, which has a hook on it. So that nut gets tightened, and then it clamps the felt and the underlay in place using that bar there. So it's nicely sandwiched in place, and we know that's a fairly good detail. So that would have been put in place when those outlets and the felt would have been put in situ. So that's kind of a good way. When it comes to refurbishment, not the best way, but a good way of refurbishing the outlets is by using one of these pre-formed with a felt flange on there. It's got a downpipe. You can see these kind of let me get my laser pointer on here. These are what's called rubber O-rings, or sometimes they're fins that stick out, and that slides into the existing downpipe, forming a watertight seal, and then this felt flange then can be incorporated in the refurbishment when using felt. So a giveaway of that when you go and refurbish, when you go and inspect the roofs, is if you can see inside, you can see this kind of metal downpipe there, and then the cap sheet will have been taken up to that and then cut around there. Blisters is another kind of common defect with felt. So blisters in any kind of roofing system is caused by vapor pressure from the underside and pushing its way out. Blisters in felt are quite difficult to photograph. You can't really see that. I've tried a number of ways of getting a good photograph of blisters, but you get the idea. And again, when surveying the roof, it's a good idea to cut open that blister, just to star cut it, see if there's any moisture within the build up there, and see if we can find out what the root cause of that blister is. Cracks in roofing felt, again, is a fairly common defect. So if the UV has attacked the bituminous surface, you'll see these kind of surface cracks here, and that's like I said, that's caused purely by kind of UV and the felt not being protected from the UV. And the other reason that you'll see cracking in felt is if it's become old and brittle, aged over time, and then it will crack then down to thermal movement or structural kind of movement. So again, you can see there where the chippings have started to come away, and you can see these kind of hairline cracks that are starting to form within the felt here. This that you can see exuding here from the laps is the bitumen. This is probably a pour and roll system where the bitumen has been left in place. And then obviously with the UV and everything, it started to crack. This fairly extreme example where we've now got a tree or a green roof starting to appear. So this is probably an old polyester oxidized felt before kind of SBS modification and elastomeric properties were added to the felts, and that's just become brittle over time. And due to thermal or structural movement, that felt now has obviously started to crack. Somebody's come along with a liquid and started to try to repair it. That obviously didn't work, and now we've got a tree trying to grow in this roof. So again, some defects are obvious when you get on the roof. Some you have to look for, but this one if trees are growing out of a roof, then it's a fair assumption that it's beyond its useful life. Okay, so moving on to single ply. So how do I identify single ply? Well, it's usually light grey, dark grey, or black, and you can usually see the seams, or you can always see the kind of seams. Obviously, if it's exposed, of course, sometimes, or a lot of the time, single ply is buried because it's loose laid and ballasted underneath stones or paving slabs or whatever. So you'll have to obviously dig those up to identify that it's single ply. And then single ply comes in a couple of different derivatives, which is plastics, all different kinds of plastics: PVC, TPO, FPO, just to name a few of the more common ones. And then rubbers is your kind of EPDMs, your Firestone kind of membranes, and they're usually black in colour. So obviously that's just an example of a ballasted roof that we come across. If you do come across it, then and you don't want to start digging, have a look at the upstands. You can usually see the waterproofing, what the waterproofing type is. Just because it's ballasted doesn't mean it's single ply. But yeah, have a look at the upstands, and you can usually tell what kind of waterproofing it is. So probably the biggest advantage of single ply is its speed of installation. It comes in like 1.3 wide rolls, and it is quite rapid to install. Obviously, it's one layer. It's mechanically fixed, loose laid, and then it's either hot air or chemically welded at the lap. So it is a speedy kind of installation on a large flat roof area with very little detail. Then single ply does come into its own. But different fixings are used, as can be seen there. So different fixings to fix the insulation down in the top left corner, usually with these like large washers on, and then in the bottom picture there you can see the fixings at the laps, and then that overlap there would be welded. And also a bar system is sometimes used in areas of high wind uplift. So with single ply, always need to do wind uplift calculations because it is loose laid, and these bars and everything, the calculations will determine whether you need to put bars in place, how many fixings are needed. This is just an example of a bar layout. You'll see around the perimeter zones and around the corner zones is where the highest wind uplift will occur. So you can see there's more bars and closer spacings around that perimeter zone. And it would be the same for any kind of mechanical fixings as well in the corners and the perimeters. So with that in mind, a common defect of single plies is when these fixings are either not installed correctly or the specifications switched. Obviously, value engineering is something that we sadly do see in the roofing industry, especially in the new build side. So wrong fixings, or when pull-out tests aren't conducted, then these mechanical fixings can come away with the bellowing of the roof, with it being non-bonded. As an example there of a core sample we've taken, you can see the metal deck here, and you can see the gap here between the metal deck and the insulation, where that insulation has bellowed, and then over time it's come away from the deck because there just weren't enough fixings there. So as you can see on this roof here, there's obviously wind is causing this now to come apart. It's not been fixed correctly, and eventually that roof will blow off and end up in the car park. So you can see that most of the fixings have started to come away there. It's just poor installation or poor design to get the wind load calculations wrong. So when we've had a look at it, we've found the fixings are all starting to protrude through the membrane. Quite extreme in some examples. So let's say with single ply, make sure it's designed correctly, make sure it's fixed correctly. But that's why we end up with the common defect of fixings coming apart. Poorly fixed, again, is fairly common defect with single plies, is have a look at the details, again, especially around perimeters, make sure that there's peel stops in place and everything like that. I say without going into too much detail, but there should be bars in place at upstands to make sure that it's secured and correctly fixed. And just a couple of examples here of when it's not. And let's say that is an example of what can happen when things go catastrophically wrong. But unfortunately, it does happen. So obviously, with any system with laps, like with felt, like with single ply, you are going to get delamination at the laps. Primarily, if it's not installed correctly, it's not been welded correctly in this instance with the laps in the single ply. But obviously, have a good look around the laps, especially again around details. It is obviously where most of those problems with delamination are going to be obvious. Blisters in single ply, not usually caused by moisture drive as it is with felt and fully bonded systems, because with single ply there are obviously bonded systems with single ply, but most of it is loose laid, and if you get a blister, it's usually a water blister where the ingress has come from a loose lap or something like that. A less common kind of defect, but it is one that I'll just bring to your attention, is loss of plasticizer in single ply. So plasticizer is injected or whatever it is into any kind of plastic product. So even like your garden, those kind of seesaws and things that you see for kids in the garden, you'll see if you leave those out in the garden over time, it becomes brittle. And that's because it's lost its plasticizer. So the plasticizer is the thing that gives it its elastomeric properties and keeps it there. Sometimes the loss of plasticizer is unknown. It can be if it's too close to an airport or that kind of thing. Single ply membranes have improved over time, generally are reinforced now. So we don't see this, like I said, as often as manufacturing processes have improved. We also see plasticizer migration with single plies as well. So sometimes when we overcoat a single ply with certain liquid membranes, we have seen where the plasticizer will migrate into the liquid membrane and turn that membrane back into liquid. We have seen that. So it's, again, be careful which kind of liquids you specify in. Make sure it's a good quality, third party accredited liquid that is approved to go over all types of single ply. Due to the fact that it's a single layer, it's around usually between 1.2 and 1.5 millimeters thick. One of the most common defects that we do see on single ply is mechanical damage. Personally, I wouldn't specify a single ply membrane on a roof that's going to receive a lot of traffic, where there's a lot of plant on the roof and things like that. Just because it is susceptible to this. You get the guys going up there doing the maintenance work, leaving screws there. Those screws get stood on, and it causes mechanical damage. Electronic leak detection is a good way of finding these kind of pinholes and things like that within the membrane. So that's just an example of that, and another example of a mechanical damage. So you can see the amount of patches and things like that usually come from doing ELDT on single ply. Okay, moving on to Mastic asphalt then. So how do we identify it? Well, it's usually black or grey in colour. It's seamless. It's solid. It usually becomes more obvious when we take a core sample. It's usually around 20 mil thick, and it's installed in kind of two 10 mil layers. Sometimes got chippings over the top of it. Should be protected again from UV because it's asphalt, because it's bituminous. It's not UV stable, so it's usually protected by chippings or a solar reflective paint, which obviously needs to be maintained every 12 months. Blistering again in asphalt is something that's a fairly common defect. Blisters in asphalt start off as what's called bumps, which are just bumps in the asphalt, which can be warmed if caught early enough, can be warmed and flattened. When they become blisters, you can see the cracking kind of in the surface. And like I say, blistering in asphalt is usually caused by a moisture build-up, so moisture within the screed or whatever, if there's not enough screed vents in there. Or if there was moisture there between the two. Like I said, there's two coats to a mastic asphalt roof. So if the first coat is wet when the second coat is applied, then you'll see blistering occur. It's sometimes from the cement dust in the buckets as well. So when mastic asphalt's installed, they'll put cement dust in the buckets to stop the mastic asphalt from sticking to the metal buckets. That cement dust can sometimes end up on the roof in small doses and can cause pockets of air, which will expand and cause these bumps or blisters. Sometimes you can go on an asphalt roof and it looks like the surface of the moon, like this one. This is obviously it's old. This one's been in place for a long time. You can see, but those blisters have obviously manifested over time. They've now got a lot of cracking in the surface, so this roof is obviously beyond its useful life now. Cracks again can occur in asphalt, as with the felt, usually down to age, sometimes down to structural movement, usually UV damage, or a blend of all of that is what we'll see is when we see cracks, and that's down to kind of thermal movement, all those kinds of things. One to look out for at the perimeters, especially when aluminium edge trims have been installed, as with this one. That metal or the aluminium will expand and contract over time, and obviously as the asphalt ages, as the UV attacks it, it becomes more and more brittle, and it can't cope with the movement within those aluminium trims anymore. So that's kind of why we end up with a crack every few meters at the perimeters, especially when there's aluminium edge trims, which there generally is with asphalt roofs, especially aged asphalt roofs where aluminium edge trims would have been used. Thermal movement, another kind of another example of it there. So you can see it straight down that line looks like an expansion joint in the slab or whatever. And the asphalt is cracked straight along there. Details, when you're surveying a roof, make sure you pay particular attention to all of the details, upstands, edge trims, all that kind of thing. It's kind of 9 out of 10 times is where you'll find these defects. The heat from the sun is what causes this. It's what's called slumping on upstands, usually kind of on south-facing areas, or where heat is reflected from other kind of building elements. At these details, metal lathes can be kind of incorporated within the asphalt to prevent this, and the asphalt should always be installed at 2 or more coats, depending on the height of the upstand. As you can see, it's just slumps off that. It's another kind of common one to have a look for. Just a few different kind of examples of it. Obviously, they've tried to repair this one with a liquid membrane. Looks like our friends Bodgett and Scarpa have been on this roof. The heat from the sun obviously causes the asphalt to soften, and anything that then is put onto the asphalt. So you can see there's obviously been some air conditioning units or something of the kind on this roof, and then you can see where the vibration from them, as well as the weight, has caused this kind of rippling effect in the asphalt here. You can also see it where the handrail supports have been put on paving slabs, but over time again it's caused the asphalt to soften and cause this kind of rippling effect. Doesn't have to be anything heavy to cause that. Like I say, this UPVC downpipe, again, just over time has sunk into the asphalt there. This is not very common, but it is a defect that we see in asphalt. This is called thermal shock, and this kind of started to happen around the times when we started to introduce warm roofs. So a warm roof is where the insulation is on the top of the deck. So you've got your structural deck, a vapor control layer, your insulation, and then your asphalt on top of that. So then what will happen is the sun will warm the asphalt up during the day, and the heat from the building, that will get absorbed into the insulation. The insulation will hold on to that heat as the temperature drops at night. So then what you've got is the temperature on the undersurface of the asphalt is warmer than the temperature on the top surface as the temperature drops at night, and that's what causes this kind of differential temperature and what causes the thermal shock in the asphalt. As we added further additives, made the asphalt more elastomeric with SBS and things like that, giving it more elastomeric properties. This kind of went away, but like I say, you do still see it to this day sometimes. Okay, again, liquid. Moving on to the liquid then. Common defects that we see with liquid. So how do we identify it? Well, it's seamless, usually grey, light grey, dark grey, is kind of what we'll see. But the thing that will give it away is like say the seamless, no lapse within the surface. Common defects, like say film thickness is probably the most important thing about a liquid system, because effectively we're manufacturing the products on the roof. So we've got to make sure that it's installed to the correct film thickness, which will be determined by the manufacturer. If we don't install it to the right thickness, then you can see these kind of glass fiber mat can be clearly seen here through the surface of the liquid, and that's a common defect, is lack of film thickness. Or with rigid GRP systems, if you put it on too thick, it will crack as well. So film thickness is very, very important when it comes to installing a liquid system. Different ways of measuring that on site. Like I said, I'm keeping this brief, so I'm not going to go into gridding out roof areas and all of the things that you can do to make sure that it's installed at the correct thicknesses. Pinholes is a fairly common defect that we see with liquid waterproofing, usually caused by moisture or again film or lack of film thickness within the build-up. So then that moisture will expand, and it will penetrate all the way through the system. When it's wet, it cause a blister, and then that blister will pop and it will cause a pinhole. Again, at installation stage, we should be checking for pinholes, filling them in, making sure that the base coat has gone down at the correct thickness, and making sure that the base coat is dry before we install the top coat. So yeah, it's just lack of inspection that causes these pinholes. What the pinholes will do is they'll suck moisture in. As that moisture then freezes and thaws, it'll expand and contract, and then causes delamination or blisters or a further kind of defect down the line with liquids. Another example of blistering, probably caused in this instance by kind of overworking the top coat or not having enough gear on the roller. Again, as the roller then travels across the membrane, it causes these bubbles which then pop and become pinholes. So it's just lack of care at installation stage. Cracks, something that we also see within liquids. This example is a rigid GRP system, where you probably get where cracks are more prevalent. These rigid GRPs are quite common now because they can be bought from any kind of builder's merchant, and I could go and pick one up tomorrow and then go and install it on a roof. So there's the training is a concern with these kind of systems. So again, if we're specifying these systems, make sure they're coming from a reputable manufacturer, installed by an approved contractor, preferably third party kind of approved, and members of a trade association such as the Liquid Roofing Waterproofing Association. It just gives you that kind of reassurance that it's a good product. Again, it's a GRP edge trim, and another kind of cause of cracking would be kind of lack of reinforcement. These liquids tend to need a bit more reinforcement at kind of joints and things like that. Again, depending on the system, depending on the manufacturer, sometimes requires what's called a bond break, so that the liquid isn't kind of bonded at these areas, so it's free to move. But again, trying to keep this to 30 minutes. Wicks is something else that's fairly common defects with some liquids that are reinforced with glass fiber matting. Quite an extreme example there of wicks, but you can see in this example here. So what that's caused again by poor installation. So these wicks should be got rid of, or they should lie down within the base coat by applying more base coat or making sure that it's installed correctly. If they are still there when the base coat is dried, they can be sanded away. The thing to notice is once the top coat is installed, there shouldn't be any wicks. If you see them, then they can, as the name suggests, wick moisture into the system. Again, that moisture will freeze and thaw, expand and contract, and cause blisters, delamination, and things like that within the liquid. So you can see here, this is blisters and delamination within a liquid gutter. Another thing to really take into account is the preparation of the surface with liquids as well. Make sure the surface is clean, make sure the correct primers are used, make sure there's not too long before in between base coat and top coat. Like I say, this is an example of delamination that we see within liquids. This is a GRP system, a rigid GRP system, as you can see or as I can tell with the fact that the base coat is clear. And this is probably intercoat contamination or something like that that's caused this kind of catastrophic delamination on here. So basically, the base coat wasn't dry, it wasn't clean before they've put the top coat over, or they've left it for too long, a couple of weeks or something like that, and dirt has then caused it to delaminate. With some liquid products, some of them are what's called catalyzed. So if the catalyst isn't installed at the correct rate, then the liquid will never cure, which is what's happened in this instance. So probably not enough catalyst has been put into the liquid, and that's caused it to still be soft years and years later. Okay, so that's the kind of the defects that are associated with all of the waterproofing kind of disciplines are the most common. So these next defects that we're going to look at now could be associated with any waterproofing discipline. So the first thing we're going to look at is poor detailing and retrofitted items, and the two of them put together. So workmanship and poor detailing is probably it is the biggest cause of defects on flat roofs. Retrofitted items by other trades are also a major cause. So if we put pipes through the roof or install air conditioning units, things like that, again, if we don't install them correctly, then it is going to cause a defect. So on this roof, as you're going to see, I mean, the felt isn't in great condition anyway, but then they've gone and installed this kind of cladding system. You can see that the base of the waterproofing is here. So they've just mechanically fixed this cladding through, and then there's water ingress now underneath around here. The right thing to do would have been to put a flashing up behind here, 150 mil high, and try not to then penetrate it with fixings, because then it's obviously not watertight. Another image, or another that same kind of image on the asphalt roof, but you can see these kind of cables have been penetrating the roof without any kind of watertight detail. In this instance, not if you can see, but they've just squirted expanding foam into there, which is again one of Bodgett and Scarpa's favourite materials. It's just squirt a load of foam in there and hope that it's watertight. Obviously, it will be for a few months until they're out of the picture, and then they can't be held accountable. Speak with a waterproofing manufacturer; they'll come up with a robust detail, which is like a cable duct with a flange on, or something like that, to make sure that it's these areas are watertight. Again, this pipe has been put through the roof. Flash band has been used, or kind of aluminium tape, which again it should only ever be used as a temporary solution. This aluminium tape, but again, it's unfortunately used by these contractors that use it as a permanent kind of waterproofing solution, which it shouldn't be. A roof light curb is again a favourite area for putting cables and things through. Again, there's right ways and wrong ways. This is the wrong way. Just drill a hole through the side of the roof light and throw the cables through. It's never going to last long. So I said 9 out of 10 times a flat roof will fail on at the details. It's usually down to workmanship, but there are a few general guidelines to take into account. Upstand height should be around 150 mil above the finished level of waterproofing. The material should be chased, if possible, into a suitable upstand and then protected. So like into a mortar chase, into a brickwork upstand, and then protected by some kind of metal or lead flashing, or proprietary lead flashing, or something like that. So that the exposed edges are protected. Again, if they can't be protected or chased, they should be protected in some ways. Some liquids can be what's called self-terminating, but again, that's down to manufacturer. So make sure you're using a good one and that they are guaranteeing it. And the materials again should be suitably terminated at the perimeter, which this isn't. This is asphalt. There should be some kind of trim on that perimeter, but you can see the brick there, and then the asphalt has shrunk back because it's not been correctly terminated, and now water can kind of ingress into this one. So this is a GRP roof that we went to have a look at. There was a lot of water ingress at the parapets around the perimeters, and the windows and things like that. So we went up and had a look at this. So like I said, they've put this GRP system on. If we have a look here, it was a felt system. So they've cut the felt away, and then they've tried to put this kind of flashing in there. Again, this is some kind of a sealant that they've used, but again, these sealants don't last very long. So the water was just getting in over this parapet, and then getting in behind the system there that had been poorly installed. So our solution was to take the coping stones off, take the system underneath the coping stones, rebed the coping stones, making sure there's a cavity closer, and the waterproofing goes straight across the cavity, making sure that that's watertight. Another way to do it would be to encapsulate these coping stones with waterproofing, but again, making sure that it's all done correctly. That's kind of what happens when you don't chase and protect. In this instance, felt onto a brickwork upstand, so it's not been chased in properly. There's no flashing over the top of it or anything to protect it, so therefore water's now getting in down the back of the felt into the waterproofing system. Time's getting on. Sorry guys, I say we're going to be 30 minutes, but I knew I had to probably take it over a little bit, but hope you can hang around a little bit longer. We're kind of on the home straight now. So the height again of upstands and details, BS 6229, which is kind of the Bible for flat roofing, says generally 150 mil should be required above the finish level. And obviously, if we're installing insulation and things like that, we should be raising those details to make sure that it's still 150 mil when we've put a system in place. We've got to be a bit pragmatic about it though as well, and whether it's commercially viable to kind of raise the upstands and everything. In this instance, it's 110 mil. It's falling away from this what's actually a bank of windows. So to raise that upstand, we would have had to remove all of the windows, put a new upstand in place, and then reinstall new windows. It's obviously going to be out of the budget of the client, so we wouldn't have done that. Most manufacturers would guarantee that detail, 110 mil falling away from the windows. In this instance though, it's a door threshold. It's around 50-60 mil, and water is kind of ingressing into the building here. So our advice here would be to raise that door threshold up to 150 mil high when we've installed a new system there. Existing drainage and roof falls or lack of roof falls, again another fairly common defect. On a flat roof, usually drains into kind of internal outlets, so we need to check those internal outlets, make sure that they're wide enough, make sure that like in this instance a refurbishment outlet hasn't been put in place and there's narrowed the diameter of the outlet. The roof falls or lack of roof falls again should be something that we're considering. As a rule of thumb, a millimetre of ponding water weighs around 1 kilogram per square metre. So if we're looking on a roof like this, so you can see this is a lower level roof. This is the curb of this roof, and these are the outlets along the outside. So this roof has deflected over time. It's now holding a lot of ponding water in the middle. You can see the concrete beams there. It's a beam and block construction, and the concrete beams have now started to deflect. And in the middle, it's around 70 mil deep. So if we're looking at that kind of rule of thumb of 1 millimetre per square metre as a kilogram, so we've got around 70 kilograms here per square metre, which is what's causing that deflection. Just an example of good falls on a roof, so you can tell that this is where it's supposed to be draining at the perimeter here. This is the ridge, and you can see the difference in height between between here and here. So you can tell that there's a good fall on this roof. Always take your spirit level. You see what's causing this ponding area here. There's actually a backfall here. So this is the drip detail with a gutter. There's ponding water here, so it's not been installed at a good fall. Condensation risk, something we should also consider when designing any kind of roof. It's not always a leaking roof. Like in this instance here, it's condensation that was causing the problem here. When we do the condensation risk analysis risk analysis calculation, easy for me to say. You see that we do the build up here, and you see that there is a build up of condensation, 2.7 grams per square meter. Over the years, then that'll kind of build up, and that'll become a problem. So that's what's interstitial condensation within flat roofs. If there's an annual build up, that kind of increases over the years, and then it will start to drip into the building. In this instance, there isn't a vapor control layer installed, so again, it's a metal deck, but it's unsealed because there's penetrations going through this roof and everything, so we can't say that it's a sealed metal deck. So it's an unsealed metal deck. So again, when we've done the condensation risk, you see there's quite a build-up of condensation in this. Okay, so what are the causes of these defects? So poor design, let's say wind loading calculations, U-value calculations, condensation risk analysis, all of these things should be taken into account when designing a roof. Poor material selection. I always say it's horses for courses when it comes to material selection. So like I said, with single ply on a wide open flat roof with not much details, it's a great system to install where there's not going to be foot traffic on there. A liquid system where there's a lot of detail, so lots of pipe penetrations and things like that. That's where kind of liquid systems would come into their own. So make sure you're selecting the right material. Budget as well comes into account, and everything like that. Poor installation, again, a major cause of roofing defects. So make sure that at installation stage we're checking that installation. We're using a manufacturer that will check that installation for you. If not, make sure that you're employing somebody, a competent person to check that installation. And lack of inspection and maintenance, again, is something that doesn't get considered often enough in these instances. So like I say, lack of maintenance and inspection. Make sure that the outlets are clear. Make sure there's no plants kind of growing on the roof. Ponding water should be checked in the gutters and everything like that. Manufacturers usually have a clause within their guarantee that says that the guarantee is only valid if it's inspected in line with British standards, which is that it should be inspected at least once a year, possibly twice a year. Make sure that we are carrying out those warranty inspections to make sure that the roof lasts the period of the guarantee. So the documentation that we tend to use, or that we have used throughout this presentation, and I say BS 6229 is the Bible for flat roofing. BS 5250 is the management of moisture, so condensation risk analysis. Your building regulations, approved document Part L, which has recently been updated. That's what's going to have your kind of U value, your insulation thresholds and things like that you should be looking for. So other courses available if you're interested that we do deliver, in-depth kind of flat roofing surveying. Like I say, this should have been a 30-minute one, but I probably talked a bit too much, so hopefully you've hung around. These are the kind of services available from myself. So if you need roof condition surveys, drone surveys, moisture mapping, all different kinds of survey kind of offerings, and then we'll put those specifications together, make sure the design is correct with calculations, preparation of tender documents, and then inspection of works, sign off, and ultimately warranty inspections. So I'll leave those kind of contact details on the screen for you. If you do have any roofing problems, then obviously let us know. Okay, let's circle back round to see if there is any kind of questions within the chat. Okay. So Shane, was the measurement from waterproofing to threshold not always 75 millimeters? So yeah, if we look like again in BS 6229, there are exceptions for door thresholds, especially where there's access, kind of flush access required. There's designs and things like that we can incorporate. It is said that it should be 150 mil But yeah, like I say, we can come up with designs for door thresholds, window thresholds, and things like that. Advice on installation of PV panels. My main advice is check the roof before you install them. I don't know how many times we see PV panels being installed over roofs where there's already cut edge corrosion kind of things in place. So make sure that that's the biggest bit of advice before installing PV panels. And again, if you want those pre-condition surveys doing, we can carry them out for you. Lead roof defects, lead roof repairs. Simon, if you want to drop me an email or something like that, if you've got any kind of a specific, I say lead roof is kind of another kind of topic. So it depends on what kind of lead roof defects that you're seeing and repair options and things like that. We can have a look at that. This CPD is being recorded. Yes, so there'll be a copy that's emailed out to you. You can download. If I cut through a blister when I'm refurbishing, how is the felt fixed back down again? Well, we do core samples when we're taking when we're carrying out condition surveys. So we put a liquid repair, usually a liquid repair, down over the top. So that's probably the best way of repairing a blister when we come and do the refurbishment. We'll be able to download. Yes, I already done that. Hi, good morning. Can you clear? Okay, I think that's it for questions. Oh, just sorry, David Morrison. How do you repair bubbling to an asphalt roof? Like I said, if it's a bump in the asphalt, then it can be warmed using hot works, usually a flame, and then flattened and softened and flattened even. So that's kind of how we would repair bubbling asphalt roof. Depends again on the level of the blistering. If there's cracks within those blisters, then it's usually that we need to kind of overlay that asphalt. It's probably beyond its useful life. Sorry. This document, for example, roof build-up and detailing. I said BS 6229 has got some in there. If you have a look again at trade associations as well, SPRA, Single Ply Roofing Association, LRWA, Liquid Roofing and Waterproofing Association, they have examples of detailing. If you want other examples of detailing, get in touch. I have got standard details that we can share. Is there any way to correct the fall of the roof without taking up the surfacing? There's what's called tapered insulation or cut to falls insulation that can be installed over the top of a roof. Obviously, it depends on upstand heights and things like that. We'd need to measure all of those. We'd need to measure the length of the fall and things like that. But yes, we can come up with what's called tapered insulation designs that can correct the fall of the roof, or certainly improve the fall of the roof. I'm just going to share a couple of documents with you before you go. So there's an example of a condition report there, and there's our brochure if you would like to download those. There's another question just coming as a thanks, Simon. Thanks, Steve. Some really great photos. Yeah, any feedback as well is always much appreciated. If you've enjoyed it, if you think there's room for improvement, then again, obviously get in touch. Any roof problems that you've got, please do get in touch. Condition surveys, anything that you need carrying out, just drop me an email. Find me on LinkedIn. You'll see lots of videos of me running around roofs on LinkedIn and everything like that. So I do try and keep people informed on what I find. So unless there's any more questions, guys, I'm gonna end this. As I said, a recording will be available. Somebody at the front door, so we'll get going anyway. It's it must be the obligatory Amazon man who usually comes when a webinar's on. But yeah, thank you again. Thank you for your time. Appreciate it's taken a bit longer than 30 minutes, but hopefully it's been useful to you. And I'll see you on the next one.